There we go. And welcome back, everyone. This is the last track, the last session for this last track. And I'm more than happy to welcome for this last one a big guest for us, Hugh McKee on stage. Hey, Hugh, how are you?
Good. Thanks for having me.
Yeah, it's a pleasure. It's a real pleasure. You're a developer advocate at Lightben, that's it?
Yeah.
And you have a lot of experience working on developing a lot of different kind of applications and so on. This is what you are covering it with this talk. Exactly.
Yeah. Yeah. Lots of experience and love doing it. And I think this will be a fun talk. It's a long title, so we're covering a lot of territory here. So,
Fantastic. So the stage is yours. Enjoy it.
all right. Thank you. Hello, everyone. Let's make sure I got my presentation. The presentation look good?
Yes,
All
it
right.
is.
Excellent. Well, welcome, everyone. Again, my name is Hugh McKee, and welcome to this talk with this really long title, Key Value, Event Sourcing, Cqrs, PubSub as a Service. And with JavaScript, I should have said polyglot because I'll show you at the end that what I'm going to be covering here really is kind of language agnostic. But we're going to be covering a lot of territory, and hopefully you'll find it informative. So the first thing I wanted to cover, though, is that this picture. It looks cool, but I wanted to give you a little background on it. So what I do a lot of my presentation materials using Blender, and Blender is a really cool tool. It's an open source tool. If you look at blender.org, it's an amazing tool that people do like movie quality video animation. I'm just like a dead novice at it, and I can do stills and so on. But I saw this tutorial, and there's thousands of tutorials on YouTube for Blender. And I saw this tutorial with this diagram or this picture, and it really resonated with me because this is kind of the way I visualize building systems in my mind's eye with all these different components that I've listed in the title, key value, event sourcing, and so on. And so hopefully at the end of this talk, you'll kind of have this, maybe a similar view of this landscape here. So the picture really meant a lot to me. So hopefully at the end, it will mean a lot to you as well. And what I'm going to be doing throughout the talk is I'm going to be showing you parts of some demo applications that I built, in particular this one, using these different components. So this is a demo application. You can see that the source code is available on GitHub under my user ID, which is McKee H3, and it's an order processing Java demo. And this demo application was built using everything I'm going to be talking about. And there's another application, I won't be really going into a lot of detail on this one, but it's similarly that another application, this was more of a proof of concept that we were doing with somebody that we're working with, trying to introducing all these different things like event sourcing and so on. So that's what we're going to be going through. And to start out, then go into key value as a service. And just kind of walk through all these different as a service things I listed out in the title, starting with key value as a service. So the idea is that the service, it's really, think of it more of an instance of a service is kind of like an instance of an object. And it's really more of a durable object. So there's data associated with this thing. And of course, that data is durable. So like I just showed you a shopping cart, an order processing type of a system. So imagine that every shopping cart instance has a representative entity, and that entity is something that, my shopping cart has an entity, your shopping cart has an entity, everybody else's shopping cart has an entity. These entities have an API of some kind, of course, a way to communicate with the entity, and they're also composed of code and state. And again, it's this durable object. So the object contains state, like what's the state of my shopping cart? What's the state of your shopping cart? What's the state of everybody else's shopping cart? Each instance of a shopping cart. So the implementation of these things is, this is a code example, and I'm going to walk through some code here for the sake of brevity and the way we're doing this presentation. Normally I would just drop into VS Code, but I took screenshots just to kind of speed things up. So anyways, this is one of the examples of a key value entity written in Java using a tool that I'll tell you about what it is at the end. But just kind of give you an example of source code implementing one of these things. So you can see there's a value entity. The second arrow here is showing a value entity. So that's kind of the indication that it's a key value type of entity. And with these entities, the API, of course, is where commands come in, requests to perform some kind of operation, like add an item to a shopping cart, change an item to a shopping cart, remove an item, check out an item, that type of thing. So commands are handled in the code via, this API. So you can see there's 3 arrows pointing at 3 different commands that this particular entity, this entity is a order item entity, which is one of the entity types that I had in the order processing system. I picked this one because it's a key value type entity, of course. So you can see though that there's overridden methods. This class is based off of a base class, and so there's a command, create order item. There's another command to ship the order item, and then there's another more of a request, but it's to get the current state, get a current view of the order item, the third arrow. So that's kind of the implementation of the API. Now notice though that in this particular way that the entities are built, this is a little unique in that the state of the entity is being passed along with the command. So there's some system here that this code is running in, and I'll tell you what the system is at the end, but you have to wait to the end, that's passing the state. So what's a little bit unique about this code is that this is a serverless kind of database list type of implementation of a key value as a service. And part of the way this system works is that the persistence of data is handled outside of our code. So there's no database connections, there's nothing like that. But I just want to point that out. I'm not going to dwell on it too much because other implementations of key values and of services and so on, would work differently. But I'm showing you a specific example here. So the state and the command are passed into my code, and what happens then is a command comes into a instance of this entity for that order item, and the code is executed against the state, and then the state changes are persisted into some kind of a state store. So this is a very CRUD-like kind of an operation: create, read, update, delete. Should be familiar to anybody that's really done any kind of back-end system development. But the difference though is that, just want to flow through here a little bit. At the top arrow up in the top left, you can see, and this, the state and command comes in, and then this is my code. I wrote it the way I wanted to write it. You don't have to write it this way, because you can see I have to implement this method, create order item, but how I implement it is up to me or up to you as a developer. So I like to keep these command methods simple, because I like to see all the command methods kind of tightly packed when I'm looking at the code. In any case, I wrote this little handle method, and then the handle method's towards the center of the screen here, the second arrow down, where in the handle method, you can see that there's the third arrow is pointing at this line where there's an update state. So you can see there's this return effects.update state. So this is the API back to the subsystem, or the system that's running my code, where I'm returning the altered state of of this durable object in this entity. Now I wrote my own little update state method that actually does the state change. And in this case, it's really simple. There's no real business logic here. It's just, it's a command to create something. So I'm just going to build an instance of the state and then I'm going to return that, and then that is going to be returned to the system, and the system is responsible for persisting this for me. So that was kind of a quick introduction to key value. You kind of retrieve an object based on this primary key. Speaking more in a kind of database terms, you execute your business logic, and then you do a create, update, delete, read, CRUD, the CRUD-like types of operations. Event sourcing gets way different. And I know a lot of people are familiar with CRUD and those kinds of operations, and I think more and more developers are getting familiar with and using different forms of event sourcing. Personally, as a developer, I love it, and I've really started using it quite a bit, as you'll see in a few minutes here. So with event sourcing, it's the same kind of thing. There's an entity, it's got an API, it's got a code that'll be executed. It maintains state. It's a durable object. But the difference is that what's emitted and what's stored by this kind of an entity isn't the object itself. It's a sequence of events. So say you're building up a shopping cart, so there's a shopping cart state. What does the shopping cart look like? Or what are all the items in the shopping cart? Things like that. But what's actually persisted by the entity is a sequence of events. So when you add one item, that's an event. You add another item, that's an event. Change an item, that's an event. Remove an item, that's an event. Check out the cart, that's an event. All those events are aggregate into the order, the current state of the shopping cart. So the implementation is a little bit different here in the code, but it's still similar in that the top arrow is pointing to, you can see that this is an event source type entity. There's different commands. Now in this case, and of course I designed this as a developer, what does my entity do? What commands does it handle? What events does it emit? That's all, my design or your design. We decide how these things look like and how they behave. But in the implementation, you can see the second arrow down, there's an add item, then there's a change item. And again, this is my code. I wrote it this way. You don't have to write it this way, but this is my style, and I like it. So what I'm doing here is, you can see there's a reject or else get. So I'm using a Java optional. So the reject method does validation, which is typical, right? You have incoming commands come in, you do some validation. Is this command acceptable to process? If it's not, reject it. So I just kind of semantically, I like the way this worked out was like, all right, if the command's okay, if the command's not okay, I'm going to reject it, or else I'm going to handle it. So let's take a look at, the reject method's pretty straightforward. It just takes a look at the I pass in the state, excuse me, the state. I pass in the command, and I just do typical validation. If something doesn't look right, I'll reject it. Now, of course, this could be more sophisticated, instead of just giving up as soon as it sees one problem, it looks at, maybe tries to find all the problems and give back a more meaningful message. But I think you get the point that I'm just doing validation here. In the handle method, though, it's a little bit different. With the key value, what happened was we updated the state. Here, what we're doing, you can see that where the arrow's pointing, it's saying return effects, emit an event. And I wrote a method called event for the state and the command. I wrote the same overloaded method for all my different commands. So if we look at the creation of the event, now what my code is doing is it's creating an event object, basically, and returning that instead of updating the state. We're going to update the state in a moment, but here what is happening is I've created an event, and that event is emitted to the system, and the system will then persist that to the journal, the event journal. And once the event has been persisted, the system will then call another method in my class that I have to implement. You can see it's an override, item changed. So you can see up above here, there's commands that I have to implement. This is kind of a contract driven type of development. In my contract, I say, what does my API look like? What commands do I accept? And I also say what events is my entity supposed to handle. So you can see there's methods for handling each of those different events. I'm going to follow through on this change item one. So we dive into the method I wrote called update state. You can see here, this one's a little bit more involved in that I need to find a line item in the order and change the quantity. So what I did was I just, up above here, you can see the method is passed into state and the event. And then I wrote this method called change line item quantity. And the bottom arrow here points to the change line item quantity here. And I'm just getting line items in the object or in the state are a list. So I just do a stream and map through that list, and I just looking for that line item to change, and when the change is made, then I update the state, and that state's returned. So it's kind of a three-stage operation. You get the command, validate it. The command's okay, emit an event. When the event is handled and persisted, then it invokes something, the code, which will then update the state of the entity itself. Now, the state of the entity isn't necessarily persisted. There is a form of snapshotting that's typical in event sourcing systems where periodically the state of an entity will be stored so that in a situation where the entity needs to be recovered from the database, say it's a long-term entity, maybe a bank account, which could have hundreds or thousands of events. You don't want to replay all the events to recover the current balance. So what happens is that periodically a snapshot of the state will be done and persisted. And then when we need to recover the state, the system will get the last snapshot and any events that occurred past that last snapshot. All that's being handled in this case by an external system. That's code that I or you don't have to write here, though, in this particular case, which is common with event sourcing. Now, that was key value in event sourcing, but the fun starts, I think, with what's called Cqrs, or command query responsibility segregation. And this is where things get a little different if you haven't really looked at this before, and if you're well, it's different. I'll just put it that way. So what's happening is that, as you can see, commands are being put into the entities, and those entities are generating events in the case of event source entities, or updating state in state stores for key value entities. But in both cases, the creation of the queryable views of data happens after those changes are persisted. So this is by design with Cqrs. Cqrs is command query. The responsibility for commands and for queries are segregated. They're pulled apart. And this is a deliberate thing, so that what you can see in this diagram here is that the entity, of course, is creating events. And then I've got a couple of views here as just as an example. What those guys are doing is when new events appear, those events are processed as fast as possible to update view data. But the view data is separate. So there's also the concept with Cqrs called the write side and the read side. The write side is the event journal. The read side are your queryable views. They're separated. They're segregated from each other. And there's also kind of an eventual consistency gap between these two, which often gives developers that are new to this, pause. It's like, oh, wow, I'm not used to this. This could cause problems. But after I've have decades of doing CRUD development, and maybe I've been talking about and doing things with event sourcing now for a couple of years, and really getting really serious into it in this last year. And let me just put it this way. It's not as bad as you think it is, this eventual consistency gap. It hasn't really caused me a lot of problems in the things that I've worked on and the things that I've seen other people do. But it really gets interesting when we do something else, which will be downstream for here in just a minute. Now, one thing I want to show you here is with this particular system, the views are defined using Google Protobuf. And you can see here that Google Protobuf is a way to define a service. So you can see there's a order item by customer by date service, I called it, the first arrow that's pointing to. And then there's they call it RPCs. The second arrow is pointing to the line where there's an RPC, remote procedure call, and there's a get method for doing a query. And the get method's passed in like a customer ID and a date, and it's doing a query based off of, you can see the SQL here to do that. There's also methods here for handling those events, updating the views. So you can see on order entity, there's this is kind of defining that I need to implement a method that will handle that event so that I can update my views. So, but that's kind of it, with Cqrs. The idea is that there's that segregation split between the write side where the events are at and the read side where the queries are at. There's separate data structures, those types of things. Now, the beauty of this kind of system, though, is that, given that everything has an API, who or what is sending commands to a given entity is, that the entity doesn't care who's sending commands. All the entity cares about are the commands something that it can process and doing the validation and so on. But here I'm showing an example of, and this is the pub sub part, where, say, instead of having a client-side API, which is feeding commands into entities, there's messages coming in from a topic. And there's this thing called, in this system, there's this thing called an action. And an action is kind of the thing at the synapse between the messaging system and the entity system, basically. So what's happening is messages are coming in from some kind of a topic. This action takes those messages in, creates a command out of those messages, and it feeds those commands into entities. So this is a form of kind of stream processing, right? The data is flowing into the system from a topic, never ending, and it's getting processed by entities, which, like in this case, an event source entity. And as I mentioned, of course, the entity doesn't care who's feeding a command, so it could very well be just a client that's doing HTTP or gRPC or something like that. So with pub sub, though, this is where things get, I think, really, really interesting. And this is why I came back to this diagram, because hopefully what's starting to emerge here is that all these little spheres in this diagram, in my mind, are specific instances of entities. And the lines between them are the linkages between these entities. So you can think of every entity as it's producing the data that it's producing. Think of it as a topic, because the changes that one entity publishes are interesting to downstream entities that are subscribing to those changes. And this is the fun part. So I kind of like thinking of this as micro streams, where I'm building an application that has a collection of these micro services that are really micro. They're very tight, they're very focused, and because they're entities, and they're part of a overall system that's linked together through these this propagation of messages, these propagation of asynchronous events, this stream of data that's flowing through a system. I love it. I think it's just a fantastic way to build applications. So this is where this diagram I'm showing the connection, where, say, the shopping cart is producing events that are of interest to this order entity. And so for example, the shopping cart's getting commands, add item, change item, remove item, and so on, but then it gets a checkout event. Orders are only interested in checked out shopping carts. So when an order sees a checked out event, then it goes, now I've got a new order. I need to create a new order entity. So this action here is also plugged into this topic, this event journal. It's consuming the messages from the event journal, but it's filtering them. It's looking to see, all right, I'm only interested in the checkout event. So if it's an add item or whatever, I don't care. But when it's a checkout, I do care. I want to grab that checkout and build a command to send to the order entity. That's the wiring together. And the beauty of this is a asynchronous messaging. So it's not the typical RESTful, like shopping cart calls, makes a request to order to do something and shopping cart's waiting for it. Quite honestly, I think that's a much more brittle type of an approach, but it's a very commonly used approach because it's so easy to implement and there's such great tools for it. But when you have the right tools and you can do these kinds of things, this is a much more robust, much more durable, and less brittle, I think, type of way of building systems. Which gets me back to the shopping cart example. This shopping cart example was built totally using what I just talked about, where on the client side, some kind of client, which isn't included in the demo, but some kind of client is sending commands to a shopping cart. Build a shopping cart, and when a shopping cart gets checked out, there's an action. The arrowhead, think of it as an action. Each of these arrows, the arrowhead, think of it as an action. That action saw that event, and it goes, I need to send a command to create an order item. Create an order. So the order gets created. When an order gets created, it creates an event that says, all right, a new order was created. Well, shipping's interested in that. So there's an action that's looking at the events that are being emitted by order. And when it sees a new order, that triggers shipping to create what I call the shipping order. When a shipping order is created, it kind of does a kind of a bill of material. It blows out the order. So say the order contains 2 items. One item of quantity 1 and another item of quantity 2. So what happens here is that the shipping order kind of opens up the order, and really what it's trying to do is prepare for it. It needs to find stock, 3 units of stock. One item has quantity 1, another item has a quantity 2. So what happens is that the action that's listening to new shipping orders getting created gets that event, but it creates 3 commands to create 3 order SKU items. When the order SKU items are created, 3 of them, in this case, this example, 3 events are emitted. This can all happen concurrently also, by the way. So there's a lot of concurrency here that's going on. So those events are being picked up by stock SKU items. But I got an arrow pointing at this action here because you can see that this action is reaching back. This little V here is a view. So these little V's in this diagram, each one of them are views that are part of this system. Well, there's one view that you can query for available stock SKU items. So that's what I want to show you next. So here's the query, the code. This is an action. And what it does is you can see the bottom arrow here, it does a query available stock SKU items. In the query, what it's doing is it's sending a command, a request to the view, do the query, giving back the results. When the results come back, the next method down, you can see it gets the response, and it looks at the response and it says, it's checked to see if it's kind of in the middle of the screen here. If the count is greater than 0, then there are available order SKU items. If there aren't available order SKU items, what the action is going to do is actually send a command back to the order SKU item and say, hey, there's no stock available for this item, put the order into a back order state. But if there is stock, it's going to move on, and then it's going to send a command to the order SKU item asking to join the stock. So this is what kind of a non-trivial action. It does a query, gets the result, examines the result, and decides what entity to send commands to. That's kind of what I'm showing here in this diagram. It's not the same part of the system I was looking at. But this action here at the top center, you can see there's an arrow coming in from a view. So this is kind of depicting that as as part of the process. So again, this order system, what happens is a client does a checkout, the shopping cart gets that checkout command, it acknowledges it, it responds immediately. Yep, I've got the command. The shopping cart is checked out. Acknowledgement goes back to the client. The client goes, great, my order is submitted. But then what happens is that then triggers a cascading sequence of events, literally a cascading sequence of events that passes through all these other entities to actually allocate stock to the order. Or in the case of, say, a situation where there's insufficient stock and orders go into a back order, another part of the system is that when new stock is added to the system, that will trigger looking for orders that need stock. So orders can be fulfilled when there's stock available, or back ordered orders can be filled when new stock arrives, that type of thing. The other thing I want to point out is that, like I said, each of these entities, these little circles that I've been using in the diagrams, there's not one of them in the system. There's hundreds, thousands, millions of them running at any single time, depending on how busy the system is. Each entity is, think of it as an object instance. It's durable, it's recoverable, it's backed up by a database, all those types of things. But there's lots of them. So there's this concept of hot state. This other system here, like I said, it's kind of a proof of concept that we were doing with somebody that we're working with. It's a really interesting application. And basically what it's doing is in this application, there's a high volume of merchant transactions that are flowing in from a topic. And they need to periodically aggregate those transactions into payments to merchants. And there was some challenges in the way the different ways that they've implemented in the past. And we came up with this design here where and I wish I had more time to go into it, but I have to tell you, this was one of the most fun things I've ever worked on as far as implementing it and coming up with a design. So the one point I want to get across was, because of the whole idea of doing things in a kind of an eventing approach, a microstream type of an approach, and really kind of embracing key value, event sourcing, Cqrs, PubSub, pulling all those things together, kind of liberated my mind and allowed me to think differently about how to actually implement solutions. And this one surprised me. The ultimate outcome of the design of the system, how it works. And again, I wish I could give you more, but if you're interested, take a look at the code. This is in my GitHub, McKee H3 transactions aggregator is called. It was a blast. So the README covers it in a little bit more detail. So just want to wrap up with, what did I use for these code examples? And it's called Calyx. This is the first time I've talked about this publicly, where right now we're in a process of renaming what we called it before, and I'll tell you what we called it before in a minute. But it's not fully released yet. It's supposed to happen in mid-May, but I was given permission to kind of tell you guys. But you're sworn to secrecy. That this isn't publicly out yet. But the new name is Calyx. We're very, very excited about it. It was formerly called Cqrs. So right now, if you want to look at documentation and things like that, you can go to cqrs.com. Within a short time, though, it's going to be called, you would go to calyx.io. And, I mentioned in the beginning JavaScript, but actually a couple things. One is, a lot of what I covered here doesn't require using Calyx. It doesn't require any particular language. And that was my main point, was to get that across, that there's different ways to look at how you build applications. And I'm a big, huge fan of this kind of microstream asynchronous messaging type of approach. I've got a lot of battle scars on me from how I built systems in the past, and this is an approach I think that works. So, anyways, it's available in a lot of different languages, and it's growing. So it's JavaScript, TypeScript, Java, Scala, Python. People are doing Kotlin and Go and more. So quite a bit. It's very polyglot. And with that, I'm done. Thank you very much for your attention, and hopefully there's some questions.
Thank you very much for this session, for this comprehensive talk of this communication strategy and so on. It was really really insightful and really interesting. We don't have that much question right now, but we still have 10 minutes. So if you have a topic that you want to cover, oh, we've got a first question. So at one of your first code slide, did you validate a state? Isn't persisted state always correct? I understand as a common validation. Maybe I missed something. So
yeah, that's a good question, and it's really the state is always trusted because, like you said, you don't want to persist invalid state. But what you do is when a command comes in, command is a request to change the state. So it's really a combination of taking the state, what is the current state of the thing, of the entity, and taking the command and looking at the two together and deciding, all right, is this command legal to change the state? And I'll give you a real easy example. When a shopping cart is checked out and say an add item command comes into the shopping cart, in that instance of the shopping cart, a checked out shopping cart, the command is going to be rejected because the state is checked out, meaning that you can't change it anymore. No more adding items or removing items, things like that. But then also in the example, I was really kind of validating the command. I was validating, all right, if the shopping cart isn't checked out, now I want to look at the command a little more closely. Is there a SKU item in the command? Is the quantity greater than 0? Those types of things. And if but it's really more validating the command.
Okay, great. Another question is there any support plan for .NET in tools like Calyx or?
Well, with Akka. Yeah, okay. I mean, there's an Akka.NET. I don't have anything to do with it. I really haven't even looked at it, but I know it's kind of a close implementation of the Akka that my company handles. And but with Calyx, there aren't any specific plans, but there's in theory it's possible. And it really is. It's kind of based on demand and how much we can handle as a company to implement these kinds of things. So it is a possibility, but as far as I know, that there's nothing specifically planned yet. But we're getting more and more questions about that.
Yeah, .NET support is not always easy to implement. So another question about distributed transaction. So what about distributed transaction with event sourcing? A compensation transaction is done after one microservice updated event journal and view?
Yeah, really good question. And in that shopping cart example, I've got a bit of kind of compensating. Actually, there are compensating actions in there because at that key point when the order SKU item is asking to be joined essentially with stock SKU items, there's that query that's performed that says, hey, give me an available stock SKU item. And what can happen is that two order SKU items can concurrently find the same stock SKU item, but only one of them is going to win. So the command comes into the order SKU, the stock SKU item that says, hey, I want to join with you. Can you join your stock with my order item? And if the stock SKU item is available, go, yeah, okay, we're joined. As soon as that state changes occurs, if another command comes in and says, I want to join with you, the stock SKU item, it actually emits an event, which is kind of a compensating action that tells the order SKU item, sorry, the stock SKU item that you picked is no longer available. You need to try again. So it is kind of, this is a form of a distributed transaction, because there needs to be a mutually agreeable set of state changes between the order wants to be allocated stock, the stock wants to be, consumed, but they have to agree. So they're actually there's conversations kind of going back and forth by emitting events, which give you the kind of that distributed transaction, a mutually agreeable change of state between multiple different things.
Okay. One question about versioning. What about updating an entity's structure? Should you keep history, or how do you version those different entities when you update them?
Yeah, another really good question. And it's kind of called, excuse me, it's often called schema migration. It's one of the challenges here, but this is a challenge with all of our long-term stored data, in that the structure of our data changes over time. So the easy answer is that hopefully the new structure of the data is backwards compatible with the old structure of the data. That's the easiest one. So that say old events were in one structure, say version 1 of this event structure, new events are in version 2 of the structure. Now, that strategy for doing that is, there's lots of different approaches for doing it. To me, the main thing is backwards compatibility, but then at the detailed level, deserializing, say, or dealing with data in one version of the schema versus another version, the technical complexities come in there, and the system has to deal with it. But that strategy is kind of universal to everything. And, and if it really comes down to, say, that there's a radical change in the new version, then the thing I like about event sourcing is that with event sourcing, typically you have all the history that you need for all the past events. So it makes it easy to, say, on the side, stand up an entirely new structure, an entirely new journal, formatted with the new version. Let that sync up, catch up, and once it catches up, then turn off the old one and enable the new one.
Fantastic. Okay. We're running out of questions, and we're touching the end of the session. So thank you very much for being with us today. It was really, really insightful and really interesting. I hope, folks, that you enjoyed it a lot, as me. You can switch to the last main stage for the last session, and don't forget the packet partnership. And see you soon for a next session, and tomorrow for the rest of the conference. Enjoy your day, and thank you again, you, for being with us today.
Oh, my pleasure. Thank you, everyone.
Bye bye.
Bye.